contains as many number of particles as are the atoms present in 12 grams of carbon-12 isotope. So, what is 12 grams for carbon? With respect to carbon, what is 12 grams? 12 grams refers to 1 gram atom of carbon, isn't it?
Yes, ma'am.
That means it's atomic mass. So, how many atoms does 12 grams of carbon contain?
6.022 into 10 raised to 23 atoms.
In other words, this is Avogadro number of atoms. So, mole is something which is representing the, you know, it's the amount of substance which contains these Avogadro number of elementary entities. So when I'm saying elementary entities could be atoms or molecules or ions, anything. Okay, so these are Avogadro number of particles in short. Got it? So number of 1 mole of a substance refers to what? It is that substance, that mass which contains Avogadro number of particles. So what is molar mass and the atomic mass we told yesterday? So gram atomic mass or gram molar mass, isn't it? This is a mass of Avogadro number of atoms. In other words, 1 mole is equal to what? 1 mole of a substance will weigh gram atomic mass or gram molar mass. Are you getting it? Is it clear? And how many particles are there? So if I take gram atomic mass, it will contain 6.022 into 10 power 23 atoms. When I'm saying molecular mass, it will contain these many molecules. Is it clear? Are you getting it? So, and one more thing, so when 1 mole is containing these many, so we can find the number of moles based on the amount of substance given. And at the same time, I'll introduce you to one more term. We have something called as a gram molar volume. So probably I would have referred to this gram molar volume little later in this. Just a minute. Huh. So can you see the screen? So gram molar volume is a volume occupied by 1 mole of a gas at ST. So, so 1 mole of a substance will occupy 22.4 liters or 22,400 cc at STP. This volume is called as gram molar volume. Okay. So if I try to connect these three, so these are the three dimensions of a mole. What is it? One is you're defining mole with respect to mass, and you're defining mole with respect to particles, and you're defining mole with respect to volume of gas. Are you getting it? See, yesterday I explained you what is Avogadro's law. So what did Avogadro's law state? What does it state? That equal volumes of all gases at same temperature, identical temperature and pressure conditions will contain equal number of molecules. I had referred to this if you remember. I said, what is it? 22.4 liters is what is, 44 grams of carbon dioxide. If I take, this is 1 mole of carbon dioxide. It's a molar mass. This will occupy 22.4 liters at ST. And it will contain 6.022 into 10 power 23 molecules. So this part was what I was referring yesterday. 22.4 liters of any gas at STP will contain Avogadro number of molecules. So volume is directly related to number of molecules. This is your Avogadro's law. So from Avogadro's law, we are deducing what is gram molar volume. This 22.4 liters is called as a gram molar volume. So same thing if I take uh, 30 grams of ethane. See C2H6. See, I'm giving different examples, students, so that you be familiar with. Every time you are taking up one example, so next time, you should not invest much time in calculating a molar mass. So the first time when I'm doing CO2, henceforth the value of molar mass of CO2 should have been registered. That should be your level of practice. So C2H6 is ethane. Ethane is a gas. So what's the molar mass of ethane? 30 grams. 30 grams constitute 1 mole. How many molecules are there in this? There are 6.022 into 10 power 23 molecules of ethane, and this will occupy 22.4 liters at STP. Believe this 22.4 liters, it's not at any random temperature and pressure. It is at STP, at 273.15 Kelvin and 1 atmospheric pressure. Okay. So these are the three dimensions of mole. Can you see that? 1 mole refers to, in terms of mass, 1 mole of ethane will weigh 30 grams. In terms of particles, 1 mole of ethane will contain Avogadro number of molecules, and this will occupy 22.4 liters. Can you see the three dimensions that I'm taking a mole? What does mole represent? A mole in terms of mass, in terms of particles, atoms of molecules, in terms of volume. So these are all molecules you saw. Just another example. Let me take 4 grams of helium. What is 4 grams of helium? This is 1 mole of helium. And how many atoms are present? Because it's a gas, it's inert gas, so it will have only atoms. This will contain Avogadro number of atoms of helium, and this will occupy 22.4 liters at STP. Are you able to, connect with whatever we have created now? 1 mole in terms of mass is gram atomic mass or gram molar mass. In terms of particles is Avogadro number of either atoms or molecules, whatever you take. Or in terms of volume is 22.4 liters at STP. This is something that you will have to understand, and you should be able to connect at every phase. Clear? Is that
Yes,
clear,
ma'am.
students?
Yes.
Yeah. So you will be able to do this, students, provided your molar mass, calculation of molar mass is perfect and you're thorough with atomic masses and molar masses. See, molar mass eventually you can calculate, but for that atomic mass is mandatory. Without atomic mass, you cannot do this. Is that clear? So how do you calculate number of moles? So let's see the three dimensions of the moles I said. So first is calculation of moles with respect to mass, based on mass. So number of moles is given as mass by molar mass or atomic mass. Okay. And from this, what is the mass of the substance? Cross multiply. Number of moles multiplied by gram molar mass or gram atom. Is that clear? Got it? So shall we do some calculations? Maybe some are there here on the screen. You can just see that. Calculate the number of moles in 240 grams of calcium. So what is gram atomic mass of calcium? 40 grams. So what is number of moles? Number of moles is mass by molar mass. Substitute. What is the mass of substance? 240. Divided by atomic mass. Oh, okay, here it is gram atomic mass. So atomic mass is 40. So how many moles are present in 240 grams of calcium? 6 moles. Okay. So just do 1 or 2 now and calculate the number of moles in. Okay, I'll give you a question like this. Which of the following has highest number of moles? Which of the following constitute highest number of moles? So eventually you find the number of moles in each case. So what's number of moles? Mass by molar mass or atomic mass. So what's the molar mass of calcium carbonate? Remember yesterday's method? Can you recollect yesterday's method? So what is mass of calcium carbonate? 20 grams. And what's the molar mass? Come on, students. Remember, students, yesterday itself I told you
100.
atomic masses should be atomic masses should be thorough. If you have this, no, whatever we did yesterday, keep it ready. Okay, you will be doing these calculations fast. So how much did we get for CO3 yesterday? CO3 was? What's the value of CO3?
Yeah.
60.
My God.
60. And calcium was
40.
40. So total is 100, isn't it? So 20 by 100. So how many moles?
2 moles.
Come again?
2 moles.
How is it 20 by 100, 2 moles? How can 20 by 100 be 2 moles here? Check the calculation.
0.2.
Yeah. Next, come on, same way. So 1.2 divided by what's the atomic mass of magnesium?
24.
So what's the value?
Zero 0.05.
Right. Next, S8. So what is atomic mass of S8? Molecular mass of S8? S8 is 8 into 32, right?
32.
Come on, go ahead. See it. So 8 into 32 is what? 256.
Zero 0.0005.
Anybody? With any different answer or you got the same answer?
Same, ma'am.
0.00.
05.
5.
Correct. Yes. That's what I want to check if you're all getting the same number of zeros. Okay. And yeah, where I will suggest you be prepared with, expressing answer in scientific notation. Can you get that? So maybe you should be aware of the scientific notation part. So what is this in scientific notation? Is it not 5 into 10 power minus 4? Remember yesterday we did it? Last 10 grams of helium. What's atomic mass of helium?
4.
4. So 10 divided by 4?
2.5.
2.5.
Yeah. Now what is the question asked? Which of the following has highest number of moles? Which one?
Helium.
Yes. So eventually you have to calculate all these things and then we'll conclude that 10 grams of helium constitutes maximum number of moles. Got it? Is that clear?
Yes, ma'am.
Next, calculation of mass using moles. If moles are given, how will you calculate mass? This is a second category. So mass is given as what? Number of moles multiplied by gram molar mass or gram atomic mass. Got it? I will give a similar question. Okay. Which of the following weigh the least? Okay, while solving this, you can finally give the answer. So individually find the weight and then finally tell me which will weigh the least. What is mass? Mass will be equal to number of moles multiplied by gram molar mass. So what is gram molar mass of carbon monoxide? Find out. And number of moles is 2.5 multiplied by molar mass. Oxygen, how much? Keep the atomic masses chart with you. So when I'm taking atomic mass, remember students, we will take it in a rounded off values. So atomic mass, suppose, what are you referring for atomic mass? Where are you referring? Are you referring to periodic table?
Yes, ma'am.
Okay, what is the value given for carbon and oxygen, Jero?
12 and 16, ma'am.
It's given as rounded value only?
Yes, ma'am.
Okay, refer to that only. Because actually, the mass of oxygen will be 15.99 something. So we always take a rounding of the digits is done here. So we'll take it as 16. Okay. So take the rounded value. Only for chlorine, it will be 35.5. Rest all rounded value. So come on, what is the molar mass of carbon monoxide? 12 plus?
28.
12 plus 16, which is 28. 28 U or 28 grams per mole. So what is mass? Number of moles multiplied by gram molar mass. So how many moles are there? 2.5 multiplied by gram molar mass is 28. How much does it make?
70.
70. 70 you're saying? Yeah. So 70 grams. Right. Absolutely right. Next. 1.5 into 10 power minus 3 moles of glucose. So find the gram molar mass of glucose. And please remember this. There are whatever, chemical formulae or the substances I'm giving in this chapter, they're very, 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 very useful. Particularly all these, you will find a wide usage in this chapter as well as in class 12. So like molar mass of water, molar mass of carbon dioxide, molar of glucose, urea, fructose, all these things, you will have to remember. For some of them, the value should have been registered. So one such is glucose. So what's the molar mass of glucose you see first? Come on, students. Should be doing fast. Carbon is how much?
12,
Atomic mass?
12,
Oxygen, 16. Hydrogen?
1.
Yeah, come on. Then what's the molar mass of C6H12O6?
180.
180, correct. So, what is the mass of 1.5 into 10 power minus 3 moles of glucose? So, 1.5 into 10 power minus 3 number of moles multiplied by gram molar mass. So, how much is it?
$270 into 10 to the power minus 3.
How are you getting 10 power minus 3 you said or plus 3 you said?
Minus 3.
Okay. 270 into 10 power minus 3. Can you arrange this in scientific notation?
Zero 0.27.
No, scientific notation. What is scientific notation, Evelyn? After first digit, you have to place a decimal, right? See, if you're writing the number as 270, I'll rewrite this here. Into 10 power minus 3. That means you will have to place it after 2. So what will be this? You should get 2.7 into how much?
10 power minus 5.
How? 270 means don't you shift the decimal 2 places to the left now? Yeah?
Yes, ma'am.
So when you're shifting the decimals to the left, what is happening? Your power will be increasing positive side.
Then 10 to the power minus 1.
10 power minus 1, or literally the value is 0.27. Are you getting it?
Yes, sir. Yes.
Evelyn, did you give me the answer as 0.27 as a final answer?
Yes, ma'am.
Yeah, got it. I know. I'm just trying to check with the scientific notation. Clear? This is correct. 0.27 is
Yes,
correct.
ma'am.
It's 200 moles of methane. So 200 into what is the molar mass of methane?
16.
16.
16. Carbon is 12, hydrogen is 1 each. So total is 16. So what will be the mass? It's quite easy. What's the mass?
3,200.
3,200 grams. I can call it as 3.2 kg, no? Right?
Yes.
See, why I'm giving you different versions is suppose in the MCQ somewhere they give this, you should be in a position to convert it. 10 power 4 moles of neon. So what is atomic mass of neon? So mass will be 10 power 4 multiplied by?
20.
Yes. So how much is it? And now express in scientific notation. 2.0 into 10 power.
5.
Yeah, 10 power 5. Is that understandable, students? Are you all able to get it?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
So I'll clear the screen. Are you done? Because we'll move on. Why I'm taking this formula, everything is there on the screen. That's why I'm not giving separately on whiteboard. Next, the next dimension is taking number of particles. So what is 1 mole of a substance equal to? 1 mole is equal to Avogadro number of particles, right? So what will be number of moles in X amount of particles? Number of moles will be number of particles by Avogadro number. Okay? Got it? Number of atoms or molecules, whatever you take, divided by Avogadro number will give you number of particles, or number of atoms or number of moles, and number of particles will be number of moles multiplied by Avogadro number. Is that clear?
Yes, ma'am.
So the same way. So let's do the first set of calculation is calculate the number of moles. Right? In our previous question, what was the question I gave? Which of them has least mass? No? So which had least mass? I just forgot that. Which of them has least mass? So carbon monoxide, I got how much? 78 grams, 70 grams. And glucose, we got 0.27 grams, no? Then neon, we got 3.2 kg. And whereas, not neon, methane, we got 3.2 kg. And neon, we got 2 into 10 power 5. So which of them has weighed the least?
Glucose.
Exactly, 0.27 grams. So 1.5 to 10 power minus 3 moles of glucose is weighing the least. So it looks like, 180 is a larger mass. But how many moles we are taking will make, that is going to constitute the mass. Understood? So calculate the number of moles. Twenty-two molecules of carbon dioxide. So how many particles are there? 6.022 into 10 power 22 divided by Avogadro number. So how much is it? What is it? What's N? Come on, students. Why are you taking such a long time? I mean, are you solving everything and answering me? So what is 8? 6.02 to 10 power 22 divided by 6.02 to 10 power 23. How much is this?
0.1.
0.1. Next. What's number of moles? 3.011 into 10 power 28 divided by
6.022 and 10 raised to 23.
6.022 into 10 power number of particles by Avogadro number. So how much does it make?
Ma'am, 0.5 into 10 to the power of 5.
Right. So what is 0.5 into 10 power 5? Is it not 5 into 10 power 4?
Yes, ma'am.
Yes, ma'am.
Isn't it? What you're doing is correct, students. I'm not saying that it's wrong, but what I'm asking is try to convert it into the scientific notation whenever you're answering. See, by and large, it's an expectation that your answer should be given in scientific notation, especially when you have powers. Okay. Otherwise, previously, we got that answer as 0.27. It's valid. You can leave it as 0.27 there in case of glucose. But here, don't leave it as 0.5. So make it as 5 into 10 power. Okay. That's the reason even your Avogadro number is also given as 6.022 into 10 power 23. Can you see? They didn't give it as 60.22 into 10 power 22. No, it's not given this way. We are writing it as 6.022 because that is the scientific notation. Is that clear? Next. Last one, quickly.
Two point four into 10 to the power 6.
Okay. How much is 1.50? Okay. 2.4 are you getting? Just check. 30 divided by 6.022 into 10 power 23. Two 2.4. After that, what did you get?
2.49.
See that 9 makes, the second decimal makes a lot of difference. And what is suggested is if you're going for both, it's expected that you give answer in 3 decimal points. Okay. Please don't leave it as it is. Because that 2.4 and 2. When I say 2.49, see, literally, if you take 1.505 is almost, it is 1/4 of Avogadro number, isn't it? So you divide 6.023 into 10 power 23 by 4, you will get the answer 1.5055. Clear?
Yes, ma'am.
So 2.49 is appropriate, or it's almost 2.5. Okay? Into
10 to the power of 6.
this is correct. 10 power 6. Absolutely right. So you would have got 0.249 into 10 power 7. Am I right?
Yes,
Is
ma'am.
that right, students? And then when you round it off, you rearrange it in scientific notation, you will get this as 2.49 into 10 power 6. Is that clear?
Yes, ma'am.
So the next dimension of mole concept is what? In terms of volume. What did we say? 1 mole of any gas is occupying 22.4 liters. So that is only what we call it as a gram molar volume. So what will be number of moles? Number of moles is volume divided by 22.4 liters or 22,400, whichever you take, depending on ml or a liter, whatever is given. And what is volume of gas at STP? Number of moles multiplied by 22.4 liters. Okay. So calculate the number of moles in 5.6 liters of hydrogen at STP. Calculate volume of 10 power minus 4 moles of ammonia. Come on, do what? Apply this, apply this. .6 liters of hydrogen at STP. So what is number of moles? Volume at STP by 22.4 liters. How much is it?
0.25.
Exactly. So 5.6 is exactly 1/4 of 22.4. Okay. So 5.6 liters makes 0.25 moles of hydrogen. What's the volume of 10 power minus 4 moles of ammonia? What's the volume? We said number of moles into gram molar volume. So 10 power minus 4 into 22.4. So what is the answer? Will you leave it as 22.4 into 10 power minus 4? What do? You have to arrange it in scientific notation. So 2, how much is it? 22.4 and 10 power minus 4 will be 2.24 because your P is ready. What is the power of 10?
-3.
10 power minus 3. So let's just look at this diagrammatic representation. I want to understand this carefully. See here. Can you see the 3 dimensions of mole?
Yes, ma'am.
Mass, volume, number of moles. Clear? So how did we get how did we get mole from mass of the substance? You divide by molar mass or atomic mass. Isn't it? How do you convert mole to mass? Multiply by molar mass or atomic mass. Is that clear? And same thing, mole, when you multiply by gram molar volume, you get the volume of gas at STP. Now, when volume is divided by gram molar volume, you get number of moles. Just now we did. Same way, when you multiply moles by a number of particles, Avogadro number, you get the number of particles, and number of particles are divided by Avogadro number, you get the mole. Isn't this what we have been doing all throughout now? Now, we will see the next level of calculation is, you are converting mass to particles, particles to volume, and volume to mass. Interconversion. Is it clear?
Yes, ma'am.
So, for that, also we have a formula, but there's an alternate route also for this. I'll give you both. You can choose any one. Both are accepted. Both are accepted by even your board. So fundamentally, the basic relation we are going to keep here is, this is the relation. 1 mole is equivalent to how much? It's gram atomic mass or gram molar mass. Okay, right? And this will constitute 6.022 into 10 power 23 atoms or molecules. Right? And its volume will be 22.4 liters or 22400 cc at STP. Keep this as your basic reference chart. Okay. Is it clear? Right?
Yes, ma'am.
So now let's see. I'll give you a question in such a way we will use, conversion of mass to volume. What am I doing? Conversion of mass to volume. Is that clear? So, how do you convert? See, for example, let me give you a question. I want you to calculate volume of volume at STP. Calculate volume at STP for 2.8 liters of 0.8 liters of carbon monoxide. Oh, no, I'm sorry. I asked you volume, no? Volume to mass. Calculate the volume of 2.8 grams of carbon monoxide at STP. So how do you calculate volume? Volume is given as number of moles multiplied by 22.4, right? Now, what is the source of calculation of number of moles in the current question? We have mass given. So I have to use this mass to calculate the number of moles. So what is number of moles in this case? It's mass by gram molar mass into 22.4. Are you getting it? So how do you convert? How do you convert mass to volume? Divide by molar mass, then multiplied by gram molar. Can you see the pathway? Divide the mass by molar mass, and the whole thing you multiply by 22.4 gram molar volume. That will give you the volume of gas at STP. So how much is it? 2.8 divided by, what's the molar mass of carbon monoxide? Sometime back only we did. Just see.
28.
28 into 22.4. In other words, what is 2.8 by 28? It's 0.1 into 22.4. You will get this as 2.24 liters at STP. Clear? Is that understandable?
Yes, ma'am.
Okay. This is one way of doing it, students. Okay, I'll explain you both the methods. The second method we have is, see our chart here. 1 mole refers to how much? Gram atomic mass, right? So 1 mole. So what is gram molar mass of carbon monoxide? 28 grams per mole. What is it? 28 grams of carbon monoxide will occupy 22.4 liters, right? Then 2.8 grams will occupy how much? You call this method as unitary method. See, it's like this. Carbon monoxide carbon monoxide, you take volume to mass ratio. Mass and volume. Okay. So 28 grams will make 22.4. So 2.8 grams, how much? Cross multiply. You will get it. What will be X? Suppose this is X. What is X? X is 2.8 divided by 28 into 22. Clear? Are you getting it? The relation will be like this. Wait. 2.8 by 28 is equal to x by 22.4. So what is x? 2.8 by 28 into 22. Isn't this the same thing we got? So you can use any method. You can use direct method or you can use a formula method. If you don't want to remember the formula, you can use direct method. Both are correct, but you have to write the steps. Say that 1 mole of carbon monoxide weighs 28 grams. So 28 grams will occupy 22.4 liters. Therefore, 2.8 grams will occupy so many liters. How much is it? 2.24 liters. I tested. Understood? Are you getting both the methods?
Yes, ma'am.
So both are correct. Both are applicable. You can use any method. Clear? Can I
Yes.
clear the screen?
Yes, ma'am.
Yes. So take this. Clear? This is what I was focusing on. This is a part. Okay. You take the formula method or you directly take this conversion chart. Everything is in this. Make a note of this. Okay. Just a minute. I'll charge my laptop. What's the order we conclude earlier was for the fourth one, no? Or maybe in this category we can take the first one here. Calculate the mass of in each case. Use the formula accordingly. You are finding mass from volume. So which formula should I use? Just see that carefully. So 6.72 liters of ozone at ST. So which formula? What will be mass of the substance? From volume. Can you see? So what do you get? You divide by gram molar volume and multiply by gram atomic or molar mass. Can you see that? Is it clear? Are you getting the formula here?
Yes, ma'am.
So what is the mass? 6.72 divided by? What is a gram molar volume? 22.4 liters. Multiplied by what is molar mass of ozone?
48.
Right, good. It's 48. Come on.
1.4 into 10 to the power of 1.
But 10 power 1 and all is okay, no problem, you can merge. The numbers are big, no? 10 power 3, 10 power 3 onwards, you start showing the power rotation. Is it clear?
Then 14.4.
14.4 what? What are the units?
Grams.
Grams. Students, are you able to get this? Anybody not able to understand? What are we doing here? Earlier was we just saw only the calculation of moles to mass or moles to volume, moles to, number of particles. But now we are going in, right, in the peripheral side. That is, you're converting mass to atoms, mass to volume, volume to atoms, or volumes to mass. All interconversion we are doing here. Okay. Next one. 6.022 in 10 power 20 atoms of argon. Six point zero to 10 power 20 atoms of argon. What is the mass? So, which formula should I use? Mass in this case is given as number of particles by Avogadro number divided by, isn't it? Mass is equal to number of moles into Avogadro number, no? Number of moles into, gram molar atomic mass or molar mass. So, what is a mode of calculating number of moles here? It is number of particles by Avogadro number. Into, what is atomic mass of argon?
The 18 months.
No. Atomic mass. 18 is
39.9.
atomic number. Yeah. Please, someone said.
39.9.
Round it up. Don't leave it as 39.9. That's what I told you. What's the
40.
rounded value of 39.9?
40.
Yes. It's 40. Now come up. How much is this? 40 into 10 power?
-3.
How much will it be?
0.04.
So many grams. Right. Absolutely right. Clear? So which of the following has least number of molecules? See here. So appropriately choose a formula from the students. Clear? Now molecules. So there is one thing, conversion of volume to molecules, mass to molecules. Accordingly, you choose. Okay? Mass to molecules is this here, and volume to number of molecules. This. So what is volume to number of molecules here? We take number of particles is what? Number of moles into Avogadro number. And it is 1120 divided by what do you do? Which figure do you give here? It is because it is in ml, I can use 22400. Got? Come on. Which? Quickly, students. Come on, students. You have to be fast. Because why I'm emphasizing so much on this mole concept, this is a basis for the rest of the chapter now. Come on, students. I'm not getting any reply.
Ma'am, 3.01 into 10 to the power of 22.
Are you getting 3.011? Check the calculation. Ah. Correct. This is 2 times 1 by 20. Correct. 3.011 into 10 power 22. Right. Next. What will be number of particles? 0.4 divided by what is the molar mass of magnesium oxide? Yesterday we did this. So magnesium is 24 plus oxygen is 16. How much is it?
40.
40 into 6.022 into 10 power 23. So how much will that be? How much will that be?
6.022 to 10 to the power 21, ma'am.
Correct. Correct. 10 power 21 is correct. Next. Volume is given. You have to convert volume to again number of moles. So what is it? It's 5.6. See, if it isn't given in liters, I will take 22.4. The volume is given in ml or cc, I'll take 22400. Okay. How much is it? See, elaborately I'm doing it, students, but if you're taking it from the CET point of view or a competitive point of view as MCQs, when you don't know, you don't have to do this depth. There I'll explain you the shortcut. But fundamental concept is this only.
One 1.5 to 10 to the power of 23.
1.5. After that, you get something else. Isn't it? You got this as
05, ma'am.
1.505. Okay. Into 10 power 23. Last 3.1 divided by what is P4? What is atomic mass of phosphorus?
31.
So it's 4 into 31. Am I right? Into Avogadro number. Are you getting the calculation here?
Yes, ma'am.
Students, who is Samsung SM-A346E? Could you unmute? Samsung SM-A346E. Who is that? Could you unmute? Ma'am, could you remove that person, ma'am?
Sir, it's me, sir.
Who is this?
Zain, sir.
Zain, Zain. Okay, Zain. Zain, please rename.
Okay, sir.
Okay, ma'am. Okay, sure. Thank you.
Yeah, what's the answer for the last one? Quickly.
1.44, ma'am.
Yeah, again 1.44 you get. Check.
Ma'am, 7.467
Oh my goodness. Oh my goodness. Why such a big value? It's a simple calculation, children.
Ma'am,
3.1. Huh?
150.
1.500.
1.505 into 10 power. Again, you get the same thing.
25, ma'am.
3.1 by 31 is 0.1. No. And this 4 will go 1.505. So into 10 power 22. Got it? The values I have given are simple values. They are not complicated values. You can easily get these answers. It's like 1 by 4, 1 by 10. Like this only you're getting the factors. Okay, so we have spent quite a lot of time on mole concept, because it's fundamentally important. This is a basis. Now, let's rush up with the concept of empirical molecular formula. Okay. So quickly, I'll tell you, how do you find the percentage composition of an element? Percentage composition is given as mass of the substance or mass of the element in the compound by molar mass into 100. Suppose I want percentage of carbon in methane. Okay. So what's the percentage of carbon? What is atomic mass of carbon? 12 divided by molar mass of methane is 16 into 100. How much is it? How much percentage of carbon? Carbon will be 3/4. What is 3/4? 75%. So what will be percentage of hydrogen and methane? 100 minus this 25%. Is that clear? So this is how you calculate the percentage composition of elements. Okay. Next, empirical molecular formula. Empirical formula is a formula based on the simplest ratio of atoms, whereas molecular formula is the actual ratio of atoms. See, for example, you take here, see the examples given here, C2H4, C6H12O6. Sorry. What's the simplest ratio of carbon and hydrogen?
1:4.
1:2, isn't it? So the ratio, the formula based on this simplest ratio is called as an empirical formula. Okay. For glucose, what is the actual ratio? 1:2:1. Actual ratio is C6H12O6. The simplest ratio is 1:2:1. So the formula based on the simplest ratio, CH2O, will be the empirical formula. Clear? Now coming to H2SO4.
2:1.
No. Try to make a simplest ratio of H2. What is the ratio? What is the actual ratio? 2:1:4, no? Can you further divide it into, make it into more simpler ratio?
Because of the 1.
I cannot write. You cannot write it as 1:1/2:2, no? It's not a whole number ratio. We cannot do this.
Yes.
So which is the simplest ratio then? This 2:1:4 is the actual ratio as well as the simplest ratio. So what is the empirical formula of H2SO4? It will be H2SO4 only. Suppose if I give you empirical formula of H2O, it will be H2O only. Because already it's in the simplest ratio and it's also the actual ratio. Is that clear? See, when I take two more examples, I'll give. Let me take C2H2 and C6H6. What is the empirical formula of these two?
CH.
Isn't it? Both of them are CH. That means the actual formula and empirical formula, they differ by a factor. Okay? That factor will tell what is that, in other words, I can write C2H2 as CH 2 times, no? And this is CH 6 times. So this factor 2 and factor 6 is deciding actually the formula of the compound, even though empirical formula is same. Is that clear? So let's see how to do the empirical formula, molecular formula calculation given the percentage composition. Okay? Is that clear?
Yes.
So take this up. Just go through this. It's a very, very simple, this one. Write the percentage composition of different elements. Divide the percentage of each element by atomic mass. Okay? So, and find the number of moles of atoms or ratio of atoms by dividing this percentage divide by atomic mass will give you the simplest ratio of atoms. Okay? Then when you each of the simplest ratios divided by the least ratio to get the whole number ratio. Suppose the simplest ratio is not a whole number ratio. You multiply by a suitable factor to make it a whole number ratio. And coming to empirical molecular formula is empirical formula N times. So N is molar mass by empirical formula mass. I'll give you a simplest question now. Okay, just take this. 1 second. Take this. Percentage of carbon is 40. I'm giving you simplest. Okay. And take hydrogen is 6.67 and oxygen is 53.3%. Okay. Molar mass is 180. Okay. Find the empirical formula and molecular formula. So what we will do is we will tabulate the same way. So what are the elements we have? Carbon, hydrogen, oxygen. And what is a percentage? 40, 6.67 and 53.3. Okay. So what is atomic mass of these elements? 12, 1 and 16. Right? So in atomic mass units, I'm giving you. So what is atomic ratio or ratio of atoms, we say? It's also called as number of moles. This is given as percentage divided by atomic mass. Clear? So what is a percentage for carbon? 40 divided by 12. And in this case, it's 6.67 divided by 1 and 53.3 divided by 16. So what is the value you get? Just check. Up to, 1 decimal point. That's also enough. Don't have to go further.
3.33.
3.33. And here, 6.67. And last one?
3.3.
3.33. Now divide each of them by the least value. Which is the least value?
3.33.
So divide 3.33 by 3.33 or 6.67 by 3.33 and last is again 3.33 by 3.33. What is the value you get?
1 month.
1 to 1.
1. No.
Two.
How is it 1? 1 is to 2 is to 1. So what is the simplest ratio of carbon, hydrogen, oxygen? 1 is to 2 is to 1. That means what is empirical formula? CH2O. And what is empirical formula mass? Find the, just like molar mass, no? Find the mass of this. Carbon is 12, hydrogen is 1, oxygen is 16. What is the value of this?
31.
30. 12 plus 2, 24. 12 plus 2, 14 plus 16 is 30. Now what is N? N is molar mass by empirical formula mass. How much is it? 180 divided by 30 will be
6.
6. Now what is molecular formula? It is CH2O 6 times. In other words, it's C6H12O6. Got it? Is that clear?
Yes, ma'am.
Yes, ma'am.
Are you clear with the way we are doing it?
Yes, ma'am.
And last is the stoichiometry, students. This is the last part, which is very, 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 very important. So, stoichiometry is a calculation based on chemical equation. Okay. So, stoichiometry, when we take a relation, we always take the relation in terms of molecules, mass, or volumes, or moles. Okay. So when you have any calculation based on chemical equation, we call such chemical equation as stoichiometric equation. And we always first step do is bring in the stoichiometric relation. So what is stoichiometric relation? Stoichiometry is anything related to that obeys laws of chemical combination. So the equation which obeys laws of chemical combination is the stoichiometric equation. Is that clear? So your balanced chemical equation is called as stoichiometric equation. Okay. So here we basically do three relations. We do mass-mass relation, mass-volume relation, and volume-volume relation. This volume-volume relation only we already did. This is only called as Gay-Lussac's law. Yesterday we did see. What did we do yesterday? Find the volume of ammonia given the volume of nitrogen. Find the volume of hydrogen given the volume of nitrogen. Did we do that? So that's a volume-volume relation. Now we will do the mass and volume relation. Okay. So let's, as we do, we will just do a question here. Calculate the mass of HCl required and hydrogen formed when 1.2 grams of magnesium reacts with excess HCl, reacts with HCl. So if I want to know this, first thing first is I need the balanced chemical equation. So what is a balanced chemical equation we have? Magnesium combines with HCl to give MgCl2 plus H2. So is it balanced? No, so I have to balance. And always first thing first is bring in the molar ratio. Okay? Because molar ratio is going to help you a lot. What is a molar ratio? 1 mole of magnesium combines with 2 moles of HCl to give 1 mole of MgCl2 and 1 mole of H2. Got it? So what is now 1 mole converted into mass? What is 1 mole of magnesium? It's 24 grams. And 2 moles of HCl? 2 into HCl is how much? 35.5 plus 1, 36.5. That is nothing but 73 grams. And in the question, MgCl2 is not asked, only hydrogen is asked. So hydrogen is 2 grams. So what is the mass of HCl reacting now with 1.2 grams? Reacting with 1.2 grams of magnesium. See, 24 grams requires 73 grams. So 1.2 grams will require how much? 1.2 divided by 24 into 73. Are you getting it? And what is the mass of hydrogen formed? 1.2 divided by 24 into 2. This will be the mass of hydrogen. Clear? So how much is the answer for the first one, HCl?
3.65.
Exactly. And next one?
Zero 0.1.
Exactly, 0.1 grams. So this is what is a stoichiometric calculation. Okay. So suppose instead of mass, if they ask volume, then it's becoming the mass volume ratio. Okay. Just a minute. Have you noted the students? I'll clear the screen.
Excuse me, ma'am.
Yeah, tell me.
Ma'am, can you explain this again, ma'am?
Okay. What is the chemical equation involved in this reaction, Evelyn?
Magnesium reacting with HCl.
What is the chemical equation?
Mg plus 2HCl is equal to MgCl2 plus H2.
Right? So it's a stoichiometric equation or it's a balanced equation. What is the information you get as soon as I see the balanced equation? See, these coefficients of reaction and reactants and products, these are called as stoichiometric coefficients. They represent the moles. So when I'm saying Mg plus 2HCl means 1 mole of magnesium is reacting with 2 moles of HCl. to give 1 mole of MgCl2 and 1 mole of H2. Is that clear?
Yes, ma'am.
What is the mass of 1 mole of magnesium? 24 grams. What's the mass of 2 moles of HCl? That's why I made you do the calculations all the way now. You know why? Because here is a quick calculation needed, conversion of mole to mass, mole to volume, all that. Okay. So 2 moles of HCl is 2 into 36.5, 73 grams. And 1 mole of hydrogen will weigh 2 grams. So the question is, calculate the mass of HCl required, which is reacting with 1.2. So what is the relation between HCl and magnesium and HCl? See, 24 grams is reacting with 73 grams. So 1.2 will react with how much? That's what I told you. This is a cross multiplication, or you call it as a unitary method. Cross multiply and get it. So what is X? 1.2 divided by 24 into 73, isn't it?
Yes, ma'am.
Same way, for hydrogen and magnesium, you take the relation. 24 is giving 2 grams, so 1.2 will give how many grams? Just a minute. Sorry. Yeah. 24 divided 1.2 divided by 24 into 7 into 2. That is nothing but 0.1. Oops. Is that clear?
Yes, ma'am.
Is that clear to everyone, students?
Yes, ma'am.
Yeah.
Yes, ma'am.
Now I'll give you another question. Can I clear the screen?
Yes, ma'am.
Calculate the volume of CO2 at STP formed when 6 grams of carbon is burnt in excess oxygen. So, what is the relation? What's the volume of CO2 formed when 6 grams of carbon is burnt in excess oxygen? What is the relation? Can you bring the equation here? Read the question, understand, identify what is the reaction. Accordingly, you give the stoichiometric equation. So what is the balanced chemical equation? Yeah, someone is saying? Please go ahead, students. I believe someone prompted. I felt so. Come on, try it out, students. Anything is wrong, I'm there to help you. What is happening here? Read the question again. Calculate the volume of CO2 at STP formed when 6 grams of carbon is burnt in excess oxygen. Burnt in excess oxygen. So, what is reacting with what? This
Carbon and
carbon and
oxygen.
so what will it form?
Carbon dioxide.
That is also given in the question. What is it formed?
Carbon dioxide.
Carbon dioxide. Is it balanced? Is the equation
Yes, ma'am.
balanced? Yes, it's already balanced. So now what is our stoichiometric relation? What's the molar ratio? What did I say molar ratio is? The stoichiometric coefficients are giving you the molar ratios. So how many, what is the coefficient? What is the number you've given before carbon? Nothing is means it's 1, right?
Yes, ma'am.
It's like you're writing
Yes,
a
ma'am.
formula. 2x plus 3y is equal to z. or you the coefficients. Same way, if I write x plus y is equal to z, what are the coefficients of x, y, and z? 1, 1, 1. Same way, what are the coefficients of these reactants and products? That is giving you the molar ratio. So what's the coefficient before carbon?
1.
1. So 1 mole of carbon combines with 1 mole of O2 to give 1 mole of CO2. Are you getting it? So convert this. So they're asking you to calculate volume of CO2, right? So what we want to bring in a relation here is a mass volume relation. So with respect to carbon and oxygen, carbon dioxide, we want a mass volume relation. So 1 mole of carbon, what's the mass of 1 mole of carbon? What is it? What's molar mass? Atomic mass?
12.
12 grams. And what is the volume of CO2 at STP for 1 mole?
44.
How is it 44, dear? Volume. I'm not asking you molar mass. Volume. What is the volume? Volume at STP.
22.4 liters.
Now tell me, why am I not asking you the molar mass? Because the question is asking you the relation as mass of carbon to volume of CO2 is the relation that's you have to bring in. Are you getting it? That's the mass volume relation. Is that clear?
Yes, ma'am. Yes, ma'am.
So is there any use of 44 grams here? Tell me. No. We don't need that 44 grams anyway. Why? Because volume of CO2 is asked, it's not the molar mass. So unnecessarily don't bring in that molar mass of CO2 here. Identify the relation. The question is calculate volume of CO2 for the given mass of carbon. Are you getting it? So that's the mass volume relation. So 12 grams is giving 22.4. So what is the mass of carbon given? If 12 is giving 22.4, then 6 grams will give how much?
11.2.
Exactly. 6 by 12 into 22.4. That's 11.2 liters. Are you able to understand now? Earlier,
Yes,
I
ma'am.
gave you the mass relation. So for the given mass of magnesium, I asked you to calculate mass of HCl, mass of H2, the previous question. Now it's a mass volume relation. And yesterday we did volume relation. Clear?
Yes, ma'am.
Yes, ma'am.
Good. Okay. So, sir,
Yes, ma'am.
shall we wind up here?
Ma'am, I think we have a few molarity and molarity left, yeah, ma'am.
Molarity, and here also a little bit of limiting and excess reagent is needed.
Yes,
The
ma'am.
last part is that only. Fundamentally, this is the main one. Limiting reagent concept is something that has to be done.
Yes, ma'am. Yes, ma'am. So, Anna, if we just overshoot by 15 minutes, could we do it, ma'am?
So I have another class right away.
Oh, is it? Okay. Fine, ma'am. We'll just discuss what we can do about it.
Sure.
Sure, ma'am. Sure. Thank
I have
you.
to end the session now. Yeah.
Okay, students, we will log off right now, and I want you guys to log in by 5 o'clock back for the physics class. We'll have the physics class from 5 to 7 students. All right, so just refresh yourself and get back for the class at 5 o'clock. Thank you, ma'am.
Yeah, sure, sir.
You can end the meeting now.
Yeah.